Actually, let's make a first look. Okay. Before we even get into this, is this by chance? Oh, it's just a sticker. Well, I expected, you know. So that's where I left off. Zooming in. And we have a manual. LCD Funkoor. And well. So, does the LCD? Yay! I like the layout of this manual. So, dear manual, my question now is, what's point 15? The zone symbol, Zeitzone, Zone. That's not terribly descriptive, is it? Explosionsgefahr. Can you connect it to some AC? No. So why the hell? Well, that's interesting. They included some warning about charging alkaline batteries. Oh well, let's see if the buttons here are self-explanatory. Well, most of them should be self-explanatory, except for the way one. Number 19. Wave das the Welle. What a that's a great manual. It's so helpful. DCF signal. So yes, this is in fact the DCF77. They only use the term DCF, but they also wrote that is the signal that's transmitted in Frankfurt, so DCF77 it is. And that this device is designed to function within a radius of 1500 kilometers from Frankfurt. And rather interestingly, it's supposed to take 3 to 10 minutes to synchronize with the signal. So yeah, I hope to wire into this thing and leave it running next to my clock. Alright, let's try to turn it on. Oh yeah, it's a bit loud. Well, the temperature in this room is quite high. Oh, alright. Here's some antenna symbol, so I'm assuming that it's going to synchronize. It takes 1 full minute for the DCF77 to send all its data. I wonder if this symbol somehow resembles the bits received from the DCF77. Maybe all that I need to do is just attach a wire to the LCD screen and read this, well, 1 or 2 segments. It is taking its time. And the antenna symbol disappeared, although it's not synchronized at all. So it doesn't want to synchronize in this room. Well, let's press the wave button, shall we? For more than 3 seconds. And this line is starting to blink again, indicating that it's trying to receive the DCF77 signal. And I really want to take it to bits, and well, it should be pretty easy to do so. Is it going to have that module that you would expect to find on eBay? Does it contain it? Or is it something else entirely? The market for this thing is a tiny bit limited. Well, Germany, Austria and Switzerland, that's not a small market. 3 countries. Germany itself isn't a small, well, it's already a huge market, I would say. Boing. Crack. Okay, that's not a crack. Oh, that's the antenna. Yay! Well, I mean, at least it doesn't have a PCB antenna. This board doesn't seem to like being screwed as hard as it is. This is just so exciting, I can't refrain from opening it and getting in there. So the antenna goes into this thing. It has a marking on it, but it's not terribly well visible. I will do something about it though. Thermal compound. I see two traces going to the blob, and there are some test points. No, they aren't test points. There's theoretically a resistor connected to one of the battery contacts, and that's a positive. Okay, so that's some pull-up resistor. Okay, so I think we've located the data line. I have no idea if this chip is going to be some ASIC purpose-built. Where's my magnifying glass? Here it is. Okay. So apparently it is ZR6100. I don't recognize this logo. Do you? And these are the test points I was talking about. No, not this one. Oh yeah, these. NORCC 2017-815. Well, that's pretty new. Well, let's destroy this thing. Although I like it so much. Power on. It clicked, so I think it's alive. So let's take a look at this pulled up thing. Oh. Did you see that? Let's change the time scale, time base. So there are some rectangular pulses. Well, it is something. It sure is sending some digital stuff. Yeah, we've got some digital signal on there, and it's 3-volt digital signal. There are two traces going into this blob, and that's the lower. Is it? Yeah, what's the other one? It definitely is some digital signal. And let's solder onto this pad. Now I wanna scrape off some solder mask off the board. And this should be just the tool for that. Yeah, this should be enough for a nice blob of solder. A drop of flux. That's enough temperature. Let the flux melt. And now let's try to get it to stick. That was scorching again. That's weird. Well, whatever, that's nicely soldered. So that's one thing wired up. So I need both wires for the optocoupler. Alright, that's nice and tinned. And now solder onto it. And it's done. Nice. So now let's move on to ground. That's an easy one. But let's add some more onto this lead without heating it up too much, preferably. Okay. Hold your tongue at the right angle and it's done. Careful with the antenna wire. Nothing seems damaged just yet. Screw this back on and see if it still works. I don't want to over tighten these screws since this PCB seems to be bending a bit. Yeah, that's reasonable. So now what do I do about these wires? I have an idea. Nail varnish. A sort of a glue. Or actually, an even better option than glue could be Captain. just a bit of tape. Let's do this. By the way, is Captain a brand? Is it like Teflon? Everyone's calling PTFE Teflon, although it's a trademark of some company, which of course doesn't like the common use of the word Teflon, since it will mean that they may lose the trademark. At least that's what I heard. I want one more piece. I am very fond of tape. Let's put the enclosure back on. This will slightly reduce the amount of clutter on my desk. So there are these vent holes, which I assume are here because of the temperature measurement capability. And they make things a bit easy for me. I didn't even need to drill a hole. Oh, this wire is so thin it goes right through. Looking good. Don't pull the wires. I'm gonna secure them with a bit of tape. Another piece of tape. And another one for the stuff that's gonna go to the logic analyzer. Looking good by my standards. This isn't looking great, but it looks like a good connection. So let's bear with this. And for this one I'm gonna evolve. My other tweezers, the ceramic ones. Yeah. Precision jobby. Making a little hook for a nice blob of solder. And I even have a blob of solder on my tip. Now, how will I know if this is pressed or not? Asking the right questions a bit too late. Or not at all. Yep, that's a sign of life. Let's temporarily tape it onto it. We do get some very nice signal. So this is looking good. Could this be UART? With some extremely low baud rate, just a bit over 3 volts, so the battery voltage, and it's gonna be perfect for my logic analyzer. That's some very slow signal. I'm impressed. And let's see the other one, the green wire. I like it that it's a pretty nice digital signal. It's so nice. And it still hasn't caught on. Well, it's not gonna be easy for it in this room. So let's move out.
When I took this clock outside where it has a stronger signal and less interference, it was able to quickly obtain the accurate time and date from the atomic clock. Both data lanes appeared to be carrying the exact same signal, which the built-in decoder in Sigrok recognized as plain demodulated DCF77. This is great news, as it means I can easily use this clock as a precise time reference for my large ISO 8601 clock Arduino project and use the readily available libraries. All that at a lower price than the bare receiver modules from eBay. Remember, it even had batteries included. I would like to thank you for watching this video till the end. If you can, please provide some feedback on how I can improve in the future. And as always, have a nice day.